So firstly, I'd say good afternoon to everybody. So, okay, hello. What happened there, Shelley? Let's do it this way around. So good afternoon, everybody. It's a great honour and a pleasure to be here, and obviously a great pleasure for Trimble to be a sponsor of the Geospatial World Forum for 2014. So what I'd like to do in the next 15 or 20 minutes is just take you through how we see the development of, or infrastructure development across the construction and workflows as they evolve utilizing geospatial information. What we're really looking here is through the whole life cycle of that asset. So it's not just through the design phase or the build phase, but also into the maintain and operate phase of the asset, as these assets have been utilized for 30, 40 or 50 years. So really we're looking here just at having there are a number of types of assets out there, whether it's civil infrastructure, you can talk about a topographic model land administration system, you can talk about a vertical building construction information model, and you get into things like rail or an airport, where on each of these infrastructure sites, information models can exist around that particular project, but then the data that's in those projects can then be used by multiple other groups over the life cycle of the asset. So if we think through which other groups could potentially use that data from a 3D type model, they basically come from the utilities, it could be the local authorities, you can get into first responders, it could be local tradesmen, and it could be the consumer as well. So there's a whole story here about how, as you go through this process, this information is becoming more and more available for multiple users to use that data that applies from a geospatial or georeference perspective around an infrastructure development project. So as we'll go through this in more detail and talk you through how we perceive that, how we see that from a civil infrastructure perspective, from a vertical building perspective, but also look at some of the conceptual ideas we see out there of how the future may be going out 5 to 10 years, of how that data may be used. Not saying it's all that way today, but how that data could be used in the future. So when you look at any construction project, through the life cycle of that project, there's three major processes. So you go through the design phase, then you look at the build or construction phase, and then you get that ongoing maintenance and operations. But within each of those processes, there's multiple tasks that are taking place where data is either being collected, it's being modeled, or it's being executed. And I think the key challenge as we look across this whole life cycle and this whole workflow is how do we ensure that data can be migrated from one particular task to the next task without it losing its integrity, or ensuring that an individual user has access to that data. Now what we're trying to build around this to enable this to happen is obviously a cloud architecture that exists on a particular project, but then a cloud architecture that exists above the project that enables multiple other people to access that element of the data. And if we think today, we go into most countries around the world, there's numerous cases where construction projects today are overrunning, either in time, in cost, or in both. And many times it's because the data being used, or different contractors or subcontractors on the sites are using different sets of data, or they're creating their own data and obviously not aligning that with other organizations' data. And that's causing the delays and the cost overruns. So how do we try and streamline that whole process, and how do we simplify that process so we hit things on time and on budget? So if we look at civil infrastructure projects, so doing a major rail project, a major road project, it effectively starts from the alignment. So tools exist today where you can actually start to build out a potential corridor for that road or that rail network, taking into account the topographic landscape of the route you're taking, the environmental issues that may exist, and the social and economic issues that may exist. Do you want to go around a city? Do you want to go through a city? Do you want to go under a city? As you start to build that out on that corridor, you then have the opportunity to get a potentially an optimized corridor or a selection of corridors where you can determine the technical issues, the social issues, but also get an understanding of the construction phase, what's going to be needed to build that particular road or rail. How many tunnels am I going to need? How many bridges am I going to need? And then you can start to build an estimation of what the cost is going to be for that project as well. So very early on in the phase, if you start to use the tools that are available today, you can start to determine or get an idea of what it's going to cost. You can start to build the budgets. Maybe there's a budget already set. Maybe the government has set a budget. Maybe the owner set a budget. But at least you can start to validate that you're in the right ballpark at a very early phase of the project. Then you start to get into the construction phase, and now with the tools that exist around data management and site preparation, the pre-construction survey can be integrated into the designer's tools, into the CAD data, and that CAD data can then be taken out to the professionals that are on the field to start the construction phase. And that can be professionals who are, whether it's surveyors going out there to do additional work, all that design data can then be put onto the machines as you start to get into the earthworks. So now you can take that data, put it onto a dozer, and start to manage the dozer through the design data come in rather than having to have the whole site staked out. Now, by utilizing the machine control capabilities in 2D or 3D, there's a high degree of accuracy. Also, there's significant improvements in productivity. So the data we've had so far over the years we've been doing this is that the advancement in productivity is around 30%. At the same time, there's approximately a 50% reduction in rework on the site. So significant efficiency benefits to be gained by utilizing the capabilities, utilizing the 3D models that now exist for doing the construction phase. Then obviously when you migrate up to the paving, again, utilizing geospatial information, geospatial technologies, you can then guide the paving machines to a high degree of accuracy. And the same for a rail project. If you're looking at a rail project, you can use georeference precision instruments to align the track, whether it's for high-speed rail on slab tracks or going onto ballast tracks. Now you look at the additional benefits that come out of this and the other benefits you can have around utilizing a connected site. So here the data is being shared at all times. So if you're a project manager on that site, you can have immediate up-to-date data of all the activities that have happened that day on the site. So what has each dozer done? What has each grader done? Where are they in the process? Are we on time? Are we on the targets we set ourselves? If not, what do we need to tomorrow to catch up? You can start to do the asset management. What assets do we have, whether they're individual personal assets or their machinery on site? If you're renting machinery, you can put capability on the machines to know how many hours that machine has been used. How does that fit in with the rental agreement we have with the heavy machinery supplier? So there's a whole host of other information that exists around the site that can be used to help a more effective and efficient management of that site. And then at the end of the process, you have that 3D as-built model that can be used and migrated into the maintain and management phase in the future. Now, the second area is looking at vertical construction, so looking at putting a building together like this or any of the high-rise buildings that we see around the world today. And always there's been a lot of talk around BIM and how that works and what BIM really is. And I think Peter will cover some of that as well, who follows me. But he's also looking at how you integrate everything in to go again from the design of the building to develop a constructible model and then pass that as-built model onto the owner or the facilities management organization. So if you think today around the architects designing the building, passing it across to the structural engineers who can then put it into a BIM model to build that 3D model where you can determine in a visual model exactly where the clashes are going to be. So you're not going out on site and suddenly realizing I've got a pipe or an HVAC running right through one of the steel girders on the project. You actually do that in the model, so it reduces the amount of rework that takes place out on the site. But then once you've got your constructible design done, you then start to migrate that to the constructible model. So you can take that information and flow it out to the fabricator. So for steel or concrete fabrication, a lot of that can now be done off-site, brought onto site at the moment it's needed, and then integrated into the building in the right location. You know exactly, you already have the precise measurements that have come from the model. But then you can take that constructible model a stage further and take it out to the trade organizations as well, because you know exactly where your HVAC is going to be, you know where your plumbing's going to be, you know where your electrical conduit's going to go. So you can give them we give them tools with precise location of exactly where they need to put the hangers up, drill the holes, etc. So you're minimizing the human input almost to a certain extent and making it far simpler for those tradesmen to go to the right place and to do whatever they need to do to help the installation. And the great thing that we saw, so as Jeff mentioned on the introduction, we completed our own building in Colorado actually a year ago. We moved in a year ago this week. But there we actually tested out some of these concepts in terms of the whole building was built utilizing this design build concept with a view we use that into operate and facilities management. And the analysis showed a significant reduction in rework on using the precise layout tools rather than using the traditional methods of doing layout. And we showed the videos and the data last year, and there'll be more information available on the booth. But again, significant reduction in rework. And again, the projects are done on time and on cost. The other aspect you can build into this model is that you can migrate it from a 3D model to a 4D or a 5D model. So you can bring time and cost into the equation. By building in some of the capabilities that now exist, you can have an initial cost, including all the fittings, going down to the last component. So if you need 500,000 screws of this diameter, that can be built into the cost model. If you decide to change the model and the change orders come in, you can update the model immediately and go back to the owner and say, these are the changes you've requested, this is going to be the cost, do you accept it, yes or no? And that's done through all the capabilities that now exist for the model. So it's done almost in a live environment. Again, specific benefits to the owner in terms of hopefully the time to completion for the project, but also the keeping the project within budget. And with our own experiences, we kept within, actually we exceeded our time expectations and were certainly well within budget. But also then when the building's completed, again, you have that 3D model that can be passed on to the owner and passed on to the facilities management organization. So we've looked there through very, very quickly through the two workflows around civil infrastructure, through the design and build, and again through the vertical construction through design and build. What I'd like to do now is just look at how you then could migrate that data into the maintenance phase or the operational phase. Now, if we look here at a typical road intersection somewhere, there's numerous, an array of geospatial tools that can be used to support the ongoing life cycle of an asset. As we said, they have long life cycles. We're seeing aging infrastructure around the world. There's limited funding to do the repairs and maintenance. But also you can, and for any agency that's responsible for the maintenance, it's a complex decision of how they prioritize whether it's repair, remodel, or rebuild. So utilizing multiple types of geospatial information and tools that are available today, we can help streamline that process for the organization that's responsible for the maintenance or operations of a particular asset. And as we see now, greater use of photogrammetry, you can start to give ongoing visualization. So if you look at a bridge situation like this, you can do your annual inspection or 6-month inspection, however frequent it needs to be done. You can take the visualization, have that picture geo-referenced, and then compare that over each specific time period, as well as taking your traditional measurement methods. At the same time, you can build monitoring solutions around bridges, dams, buildings to gauge what is happening on a 24/7 basis with that particular structure. But then in a situation here, you could say on that particular piece of bridge, you know exactly which company and which batch of concrete was poured or where that bridge was fabricated. Now, was a bridge was fabricated at the same time using the same batch of concrete? If this bridge is deteriorating, the other one's in similar climate conditions, etc., you can almost guarantee there's going to be another issue with the other bridge, so you can start to predict where your maintenance requirements are going to be. I think the other interesting area to start thinking about, and I challenge all of you just to think through, is who are other potential users of the geospatial data or that 3D model data as we look through the life cycle of a particular asset, whether it's a road, a rail project, or a building. So we've already talked about monitoring how that asset can be monitored using various geospatial capabilities. But I think you can also get into the utility companies. So rather than them having to walk into the building, whether they're gas or electric or telephones or IT companies, they actually have that model of exactly how the building was built and where all the utilities are. So they can go straight to the location and know they're going to find the right cable behind the wall, rather than today where they're having to scan it to see if they find the right cable, or maybe they're having to use a little bit of guesswork. So again, that capability starts to come out of utilizing the 3D model. And obviously, the model can be a live model. It doesn't need to be a static model. So as maintenance work takes place on the building, as people move around the building, cables move, you can continue to update the model so you've got a continuous live model of the total asset. Also, you can start to look, and I was talking to one of our colleagues last night, around can you start to build that 3D model into the planning process in a particular country. So a lot of people are now looking at 3D geospatial models, 3D cities, and today there's some organizations who are starting to build out that 3D capability from a land administration perspective. Can you now start to have that 3D model going into the planning organization to get planning approval from a 3D model perspective? This is one of our frustrations in our own building, that the City of Westminster did not have the capability to take our 3D plans. We had to go and develop 2D plans just to submit the planning application for the building. So we're now trying to work with them to educate them that they should be looking at taking in 3D plans. And then maybe in the future we'll see, as we start to build out greater capability around 3D, that it links into indoor mapping. And there's a lot of other organizations are talking about how you build out indoor mapping capabilities for both the professional user but also the consumer. So if you then look out into the future, how do we see that the future is going to operate here? So is there a time at some stage in the future, yet to be defined, when the construction worker is going out to the intersection at the corner of the building here and has to do some construction work or remedial work, rather than having to go and look at the plans and try and figure out where all the utilities are, can actually take a smart device of some description, hold it over the tarmac, and actually see a 3D model of exactly what's there beneath the surface. Now, are we there today? No. But is there a time in the future where we will be there? Absolutely. And I think as we start to build out and utilize the capabilities, you start to put the building blocks in place to build out that sort of model. And obviously it takes time to get there from a global perspective, but as little pieces start to come together in the jigsaw, you start to put the bigger picture together. Then the last one here is looking at, again, conceptual idea of actually turning up in a building when we're all wearing heads-up displays, whether they're Google glasses or some other heads-up display. You're looking for the company you're looking for is somewhere up on the higher floors. Rather than having to look at a whole long list, your Google glasses tell you exactly which floor you need to go to. Or do you have the concept where at some stage in the future, a firefighter, first responder turning up at a fire has a heads-up display that has a 3D model of the building in his or her heads-up display, so they know exactly where they're going, but also they know exactly what's behind the walls. They know where the gas pipes are. They know where the electric cables run. So there's some of the ideas, I think, of how we can see this infrastructure, this 3D model of infrastructure development going from the design build, but into that operate and maintain phase, and being utilized probably by far more people than we can actually imagine today could utilize that information at some stage in the future. So I hope you find that just enlightening and a vision of how we can do things today, but also how some concepts and ideas could be coming in the future. Thank you very much.